Hey guys, it's me, Miss Moncrief, trying to give you, presenting the new lesson for you. Today we're looking at lesson 10.7, probability in two-way tables. So let's remember, probably from your 8th grade year, experimental probability. So probability is a ratio that compares how many times an outcome can occur to all the possible outcomes. That's just like if you roll a dice, what's the probability of you rolling 4 on a 6-sided dice? So how we kind of set it up is the P of the event, so this looks just like our function notation, is equal to the number of times the event occurs over the total number of outcomes. Something else we can say if we're not looking at events is part over whole. Part over whole. So like when we were talking about the dice, if we wanted to roll 4 over what's the total number of sides the dice has? 6, and that's how we'd find the probability. So let's remember a couple of things. Probability can be written as a ratio, which is just a fraction, or a percentage. So it says, what is the probability that an event is certain to occur? Think of weather. If it is certainly going to rain, what's that probability it's going to be? If it's definitely going to rain that day, that is a 100% chance. So the probability would be 100%. Now, what is the probability that an event will never occur? So that's like if it's definitely not going to rain at all today, ever. That would mean you have a 0% chance of rain. Or a 0% probability. All right, so let's look at a couple of things. So we want to suppose you have two number cubes, one blue and one red. It says the role of each number cube is an independent event. So we're going to talk about independent probabilities first. In other words, rolling the blue cube does not affect the outcome of rolling the red cube. Independent, that just means one won't affect the other outcome. Okay? So now this says, what is the probability of rolling a 3 on the red cube? So how many sides do we have the 3 on? Well, only one side, so that would be your part. And then how many sides on a dice at all, or how many sides are there total on a dice? Well, that would be 6. So our probability is a 1 over 6, or let's make that a percentage. So 1 divided by 6 gets us a decimal. So 1.1666666 all the way to 7. Let's time that by 100. And then round the whole number up to 17%. So you have a 17% chance of rolling a 3 on the red dice. Sorry, that just looked gross. So, and the way we kind of set this up is the probability P of red 3. So if we're doing probability of red, you want to put red, and 3 is the side we want. All right, so now it says, what is the probability of rolling an even number on the blue dice? So when we set it up, we have the probability of blue even, but now we got to think about how many even numbers are on a dice. Well, the numbers are 1 through 6, so 1, 2, 3, 4, 5, and 6. Which of those are even? All right, 2 is even, 4 is even, and 6 is even. So how many numbers do we have that are even? 1, 2, and 3. So we have a 3 out of how many? 1, 2, 3, 4, 5, 6. 6 chance. But now let's go ahead. If we want the fraction, we want it in simplest form. So can we simplify the fraction 3 over 6? Yeah, they're both divisible by 3. What's 3 divided by 3? Well, that's 1. And what's 6 divided by 3? 2. So our simplified version of 3 over 6 is 1/2. Remember, if you can't remember how to simplify a fraction, you can always go alpha y equal 1, 3 over 6, and then click enter. And that gets you 1/2. But we also want the percentage. So what's 1/2 as a decimal? 1 divided by 2. Multiply that times 100. And we have 50. So we have a 50% chance of rolling an even number on the blue dice. All right. So now let's look at, sorry, that was just in the way. Let's look at rolling the cubes at the same time. What is the probability that you will roll a 3 on the red dice and an even number on the blue cube? So that means when we have a probability of 1, so when we have 2 probabilities we're looking at and it says and, that means we're going to multiply. If it says and, we want to multiply. So what we'll do here is first find the probability of the first one. What's the probability that we roll a 3 on the red dice? Well, luckily we already found it, so let's use that fraction 1 over 6. And then we want a probability of a blue even. Well, we've already found that, so let's do that. Use that fraction. Use the simplified fraction, 1/2. So 1/6 times 1/2. What is, just kidding, don't do that. We want to use the fraction we got at the beginning. So what's the beginning fraction? 3 over 6. So 3 over 6. What's 1 times 3? 3. And then what's 6 times 6? 36. And then we want to simplify that fraction, or get that fraction as a percentage. What's 3 divided by 36? That's 0.083 times, nope, not divided, sorry, times 100. And what do we get? And we only want to the whole number, so that would be 8%. You have an 8% chance of rolling a 3 on the red dice and an even number on the blue dice. All right, so now let's look at another possibility. So we're rolling the cubes at the same time. What is the probability of rolling a 2 on the red cube or a 5 on the blue cube? So this is different from the first one. This is an or problem. If you see or in it, that means you are going to add the probabilities. So first of all, we need to know the probability of 2 on the red cube. Well, how many sides do we have 2 on? 1. So we have 2 over, not 2 over 6, 1 over 6. So that's 1 over 6 for the red, the 2 on a red dice. And then a blue, or 5 on the blue dice. So how many sides have 5 on them? 1. So that's 1 over 6 again. So 1 over 6. And then what's 1/6 plus 1/6? Well, remember to add fractions. Then you have like denominators, do they? Yes, they both have 6. So bring that denominator over. And then add the numerators. What's 1 plus 1? 2. So we have 2 over 6. And can we go ahead and make that a percentage? Yeah, we'll just do 2 divided by 6. What do we get? 0.333 repeating. Multiply that by 100 to get our full percentage, and that is just 33%. And that's how you find the probability, especially when looking at cubes. All right. So now let's look at this one. Probability is written as fractions, can be used as proportions to make comparisons. So easiest way to remember this, probabilities, we want the percentage. Proportions, we want the fractions because we want to be able to make comparisons. So let's look at these spinners. So it says find the likelihood of each event for each spinner. This is the proportion of each number on the whole. So we just want the proportions. So let's take a look at the first one. We have this spinner. Let's always figure out the whole first. So what is the whole number we have? How many sections on the spinner do we have? 1, 2, 3, 4, 5, 6, 7, 8. So when we know that we're doing part over whole, we will know that the whole will always be 8. All right, now let's look at what the probability we're looking for is. So this one says P5. P5. That means we want to see how many times, what's the likelihood we will spin a 5 on the spinner. So let's see how many options have 5 in it. I'm going to highlight them in green. Yeah. 1, 5. All right, there we go. All right, we just have the 1, 5. So that means we will have part 1 over whole 8. So my proportion, my likelihood would be 1 out of 8. 1 over 8. Now let's do the next one. We have probability of landing on a 3. So let's find all the 3s. 1, 5, 1, 1, 3, 2, 2, 3, 3 3s. So how many parts do we have that are 3? 3. And what's the whole still? 8. So we have the probability of spinning a 3 is 3 over 8. All right. Now let's check the next one. Again, we always want to make sure that we know what the part is, we know what the whole is first. So let's figure out what the whole is. 1, by counting up all the sections. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 total spots on the spinner. So the whole again is 8. Everything will be over 8. So we want to know what's the probability of spinning a 5. Let's highlight all of those in green again. Here's a 5. Here's a 5. And that's all the 5s they have. So how many 5s do we have? 2. So we have 2 over 8. Now let's check the next one. We have the probability of spinning a 3. How many 3s do we have? 1, 2. So this one also has a probability of doing 2 over 8. So if they're both 2 over 8, they have an even chance of rolling either. All right, now let's check the next one. C, we have how many? Let's find our whole again. So 1, 2, 3, 4, 5, 6, 7, 8. Again, this is out of 8 possibilities. We want to see P5, the probability of spinning a 5. Let's see how many 5s we have. 1, 2, 3. So we have a 3 out of 8 chance. Now let's check the probability of spinning a 3. So let's find our 3s. 1, 2. We have a 2 out of 8 chance. All right, and now let's check our last one. Again, we want to know what the whole is. So let's count our parts. 1, 2, 3, 4, 5, 6, 7, 8. So again, it's over 8. And then we want the probability of rolling a 5. So let's highlight those in green. 1. And that's it. So we have a 1 out of 8 chance. All right, and now let's check the probability of spinning a 3. 1, 2. All right, so that's another 2 out of 8 chance. So now it says, which spinner has a greater likelihood of landing on a 5 rather than a 3? So we found the probability of finding us landing on a 5 and on a 3 for each one. So when we're comparing these, we just want to see which one has the higher numerator. So on the first spinner, we have 1 and 3. 3 has a higher likelihood. On the second spinner, we have 2 and 2. They have the same likelihood. On the third spinner, spinner C, we have a 3 and a 2. So 5 has a greater likelihood. And then on the last one, we have a 1. 5 has a 1 and 3 has a 2. So 5 is less likely to be landed on. So that means our answer is C. C has a higher likelihood of landing on 5 than 3. All right, so now let's look at organizing data in a two-way table and then finding the probabilities or proportions. So a two-way table is just the easiest way to think about it is a Punnett square. So you know when you did those in science, there was like brown hair, or like you had brown recessive, so it was B little b, or brown dominant for hair, big B, and then you just kind of combine those in there. So it's kind of like that, comparing them and looking that way. So let's look at it. We say the Venn diagram shows the results of a survey in which 80 students were asked whether they play a musical instrument and whether they speak a foreign language. And we want to use the Venn diagram to complete the two-way table. So here's our Venn diagram. Now, so we have a total of 80 students that we took. Let's look on the inside of the circle. So the red circle said 25 of them play an instrument. So that's 25 just play an instrument. So that means they play an instrument, but they do not speak a foreign language. So that would be 25 students. And then we have 16 play an instrument and speak a foreign language. So play an instrument, speak a foreign language, there's your 16. And then we have does not play an instrument. Oh, wait, no. Now we want to look at the blue circle. It says speak a foreign language. So these are students these 30 students just speak a foreign language. They speak a foreign language, but don't play an instrument. So that would be 30 total students. And also you notice out here on the ends, we have totals. That means we want to add up everything. And then, all right, but let's backtrack a little because we got one more section I forgot about. Then we have all this around the two circles. We have this 9. That's students who don't play an instrument and who don't speak a foreign language. So doesn't play an instrument, doesn't speak a foreign language. That's those 9 students. So now out here on the side, you probably see totals. That just means we want to have the total of students who speak foreign language, who don't speak a foreign language, who play an instrument, who don't play an instrument. So let's look at speak a foreign language. What's the total of students that speak a foreign language? Well, that would be 16 and 30. We'd have to add those up. So what's 16 plus 30? That's 46. All right, now we want does not speak a foreign language. Now we want the total of students who don't speak a foreign language. So that would be 25 and plus 9. So what's 25 plus 9? 34. And now I want the total of students who just play an instrument. So that'd be 16 plus 25, which would get you 41. And now we want students that do not play an instrument, the total of them. So that'd be 30 plus 9, which gets you 39. And in the end, just to kind of check yourself, you'd also want both of your total sides to theoretically equal the same numbers. So how many students were totally surveyed? 80. So let's make sure that between plays an instrument and doesn't play, those add up to equal 80. So what's 41 plus 39? Oops, that's a 6. Well, that's 80. So we did it. Now what's 46 plus 34? There's another 80. So we did good. We added our totals together great. And when you see when you see a two-way table, more than not, they're just going to have the numbers. They're not going to have the proportions, the percentages in them. But we're going to include those while we go through it. So it says one student is selected at random from 80 students who took the survey. Find the probability that the one student, part A, says plays an instrument. So when we just want to see the probability that a student selected will play an instrument, we'll go to play an instrument, and we'll go to all the students that play an instrument. So overall, we have 41 students that play an instrument. To get that probability, we do the 41 part of the students that play an instrument over the whole students that were total, which was 80. So 41 over 80. And then what's 41 divided by 80? Well, that's 0.5125, but remember, percentage times 100, so times 100. And that gets us 51%. Remember, we round to the nearest percent. All right, so we have 51% of students play an instrument. Now we want to know the percentage of students that speak a foreign language. So we'll go to the total of students that speak a foreign language, which would be 46. And we'll do 46 over 80. And what's 46 divided by 80? Well, that's 0.575 times 100. 57.5, so round to the nearest point, which would be 58%. So the percentage of students that speak a foreign language is 58%. So far, that wasn't too bad. Now we want to look at plays an instrument and speaks a foreign language. Plays an instrument and speaks a foreign language. So that means we'll go to plays an instrument, speaks a foreign language. So what percentage of students play an instrument and speak a foreign, or what number of students play an instrument and speak a foreign language? Well, that's 16. So we do 16 over 80, which would then get us 16 divided by 80. 0.2 times 100. Well, that'll get us 20%. So 20% of students play an instrument and speak a foreign language. Now let's look at the percentage of students that does not play an instrument and does not speak a foreign language. So let's start by going to the does not play an instrument. And let's go down to where it meets does not speak a foreign language. Well, that's 9. There's 9 students that do neither. So we do 9 divided by 80. That's a 0.1125. And we'll multiply that times 100. And we'll get 11.25, or just 11%. Now, I know you're sitting there, Miss Moncrief, those are already there, but you have to make sure you know how to do it. All right, now we want the number of students that plays an instrument and does not speak a foreign language. So what number of students play an instrument but don't speak a foreign language? Well, that's 25. So we do 25 over 80, and we get 25 divided by 80. And that gets us 0.3125, so times 100. That gets us 31.25, or 31%. So we have 31%. Now, 31%. And those are the only ones we had to look for in the immediate. But why don't we go ahead and check out the rest of them real quick. So if we did does not play an instrument but does speak a foreign language, we'd have 30. So 30 divided by 80 gets us 0.375. So times 100 gets us 38%. And what about students that just don't play an instrument? That's all we care about. So we do 39 divided by 80 and times that by 100. And we get 49%. And now we want our students that just don't speak a foreign language at all. So that means we do 34 divided by 80 times 100. And we get 43%. 43%. Okay. Now let's go a little more in depth. Let's look at this next table. So, the table shows the results of a random sample of 60 people about their eye color. So, we have about their eye color and about their hair color and their eye color. So we have the hair types: red, black, brown, red, blonde, and total. And then we have the eye color: brown, blue, hazel, green. So we have a person is selected at random from a sample. So we want to look at, first off, the number, so we want a person selected at random from a sample. Find the probability. Probability is percent for each of the following. So we want to know what's the probability that that person had brown hair. So we want to go to brown hair, and it just says brown hair. It doesn't give us anything else. So we want to look at what has brown hair. So how many total people have brown hair? That's 28. So we have 28 over, what's the total number of people? 60. So we have 28 divided by 60 gave us 0.46 repeating, so times 100 enter, and so that means we got 46.6, round that up to 47. That one was pretty good. We've done one like that before. Now we want to look at the likelihood that that person does not have hazel eyes. Like, does not have hazel eyes at all. So in order to figure that out, we first have to figure out how many people have hazel eyes. Well, that's 9 people have hazel eyes. So how many people don't have hazel eyes? Well, that would just be the total of people minus the people who do have hazel eyes. So it's 60 minus 9. It's supposed to be 9. Well, that is 51. So that means we have 51 over 60. 60 because that's our total amount of people. And then what's 51 divided by 60? Well, that's 0.85 times 100. 85. So that's 85%. Okay. So now we want to look at hazel or green eyes. Hazel or green eyes. So let's think back to the beginning of the lesson when I said and. I forgot to mention that up there, but when we said and, what did we do? We multiplied, and it was really easy to find the ands in the table. But we multiplied, but what do we do when it says or? When it says or, we're going to add. So let's think about the hazel or the green eyes. So let's think about the probability that someone would have hazel eyes. Well, that would be, what's the total of hazel? 9, so that'd be 9 over 60. Remember, or add. So that's 9 over 60. And then green. So what's the probability of green? 7. So that's plus 7 over 60. You could just plug those into your calculator, but remember, do they have the same denominator? Yes, absolutely. So we just have over 60. And what's 9 plus 7? Well, that's 16. So we have 16 over 60. Now let's find that probability by doing 16 divided by 60. And what do we get? 0.26 times 100. And that's 26.6 repeating, so really just 27%. You have a 27% probability that the person you would select has hazel or green eyes. Let's do another one with or. So this has black hair or red hair. Remember, or means we're gonna add. Very good. So what's the probability that a student has black hair? Well, that's going to be 12. That's 12 total students who have black hair. So 12 over 80 plus, what's the probability of students have red hair? Red, that's a total of 7. So 7 over 80. I did 80. I really meant 60, y'all. So that should be 60. So let's add those together. Keep the same denominator. And then what's 12 plus 7? 19. So we have 19 over 60. And then what's 19 divided by 60? And again, times 100. Well, that's 31.6 repeating, or just 32%. All right. Let's keep going. Let's go on to E. E says brown hair and blue eyes. So that would be that point where brown hair and blue eyes meet. So here's brown. Let's meet it at blue. So that's 8. So we have 8 over 60. What is 8 divided by 60? Well, that's 0.13. So times 100 would just be 13%. I hope you guys know other ways to change decimals into a percentage. You multiply by 100, or you move that decimal point to the right twice. So 13%. All right, and we have another one that says and. So we have brown eyes and red hair. So let's go to the brown eyes. There we go. Now let's go meet it at red hair. So that would be the and, that 3. So we have 3 over 60. And let's find that percentage. 3 divided by 60. 0.05 times 100. And that gets us 5%. There we go. All right. So now we want to know which is more likely. So we have black hair with hazel eyes. So that with is just another way of saying and. Black hair with hazel eyes, or blonde hair with and green eyes. So that means we have to find the probability of both. Let's do black hair, hazel eyes. So that would be 2 over 60. And then what's 2 divided by 60? Well, that's 0.03 repeating times 100. So that's 3.3 repeating. So that's just 3%. And now we have blonde hair. That's percent sign's really ugly. Now we have blonde hair with green eyes. So blonde down to green, that's 2. So that's again 2 over 60. What's 2 divided by 60? I hope you're beating me to it. Times 100. And that's again just 3%. Oh my gosh. They are the same percentage. If they're the same, that just means they have the same probability. So they have the same probability. And that's no big deal. Okay. Dodo. Okay, so let's continue our probability stats journey by talking about compound events on a two-way table. So the first one, we have a probability of A and B. So if it's and, we'll do a product. We kind of talked about that. It's for when both events are in a single cell within the table. So the probability of A and the probability of B will be like the probability of A times the probability of B. The probability of A or B or signifies independent event. That means one where the other happens. These events are in both rows or both columns. So remember, if it says or, that means we will add. So that means we have probability of A or probability of B is equal to probability of A plus probability of B. And then we have the probability of or dependent. So there's two kind of ors. We either have independent or dependent. Dependent is when one event is in a row and the other is in a column. So the probability of A or probability of B would be probability of A plus probability of B minus probability of A and B. That'll make more sense when we're looking at it. It's when the cells, it's this cell where the row and column are overlapping. So let's keep going. So let's look at example 3. Example 3, we have 100 students were surveyed about which superpower they'd like. These results are shown on the two-way table. So this goes ahead and tells us what's our grand total of students? 100. So everything will be over 100. Use the table to answer the questions, then write your answers in both reduced fractions and percentages. You need to make sure you're reading these questions, the directions up here very carefully, because this time we want the reduced fraction and the percentage. We got to have both. So let's look at the first one. It says, what is the probability of a student being male and choosing invisibility? So that means that he would be a male and he would choose invisibility. How many students were male and picked invisibility? Well, that was 12. So it says find the cell for male and invisibility, find where they cross, and then that would be 12. So we'd have 12 over 100, reduce that to 3 over 25, or 12%. So we would want both of those answers. These met up in one single cell on the table. On table. All right, now it says, what is the probability of a student choosing flying or invisibility? flying or invisibility. So now we're looking at two superpowers. We're not looking between power and gender. We're just looking between two superpowers. So we have flying, that's 38 total, and we have invisibility, that's 44 total. So we're looking at these two. These are in 2 rows. So we'll have to add them up. That means we'll have 38 over 100 for the probability of flying and 44 over 100 for the probability of invisibility. Then we get 82 over 100, or 82%, and we can simplify that 82 divided by 100. Math, enter, and get us 41 over 50 for our reduced fraction. All right. And now we have, what is the probability of a student being male or choosing invisibility? Male or choosing invisibility. So let's figure out what the probability of being a male is. All right, here's the probability of being male. And then here's the probability of being invisible. So we have the probability male, 48 over 100 plus 44 over 100 minus the overlap. So that would be minus the probability. Okay, so let's start that question over again, because I was forgetting some things. Okay. So let's go back to the probability of a student choosing flying or invisibility. So that means we had 2 rows, flying and invisibility. We were looking at those two there. Those are parallel. If it's parallel, you're just going to add. When you can draw a line through the table and they're parallel, you're going to add them. So let's take a look at what happens when we do C. C says, what is the probability of a student being male or choosing invisibility? So let's highlight all of the male column, because that's what we want to look at. Okay, let me redo that because that's just ugly. Highlight the male column. All right, and the number we want to look at is that total, because that's the total of males that were surveyed. Now let's highlight the probability of invisibility. All invisibility row. Well, and then let's go ahead and circle the total, because that's the probability of being invisible. These lines, instead of them being parallel, they cross each other, right? So that means we'll take the probability of either being male or choosing invisible, so 48 over 100 for male, 44 over 100 for invisible, and then we'll subtract the overlap. So the overlap would be this 12, where it's either male or male and invisibility, so 12 over 100, which then we would get, so now we have 48 over 100, 44 over 100, minus 12 over 100, which gives us 88 over 100, which the reduced fraction would be 22 over 25, or 88%. This would be like, this would give us a column plus a row minus the overlap. So yeah, let's look at a couple more examples with that. All right. Trying to erase this. Now let's see. We have, what is the probability of a student choosing flying or being female? Well, let's highlight the entire flying row first. So we have flying. And now we want or being female. So let's highlight the female row. So these overlap. So that would mean we have, what's the probability of flying? All right. That's 38 over 100, because 38 students chose to fly. And what's the probability of being female? Well, that's 52 over 100. And then what's the overlap? Well, that would be 12 over 100. So minus 12 over 100. And again, since we're subtracting fractions and all those denominators are the same, we just need to subtract our numerators. So, or combine our numerators. 38 plus 52 minus 12. And that gets us 78 over 100. Over 100. Now let's see what that is as a reduced fraction. Alpha y equal 1, 78 over 100. And that gets us 39 over 50 for our reduced fraction. And then 39 divided by 50 times 100 gets us 78%. So you either have 39 over 50 or 78%. All right, let's do another one. That big so we can erase it easier. All right. So now we want to know what is the probability of choosing other or flying? So let's see what we have. We have other, and then we have flying. Now those two roads are parallel, so we're just going to take their totals. So we'll take 18 over 100 and 38 over 100. So it's 18 over 100 plus 38 over 100. It's 18 plus 38. It's 56. So 56 over 100. And then equals 1. 56 over 100 will give us 14 over 25 for our reduced fraction. And then 14 divided by 25 is times 100 is that 56%. So we have 14 over 25 or 56%. And then our last one. Now it says, what is the probability of a student choosing other and being a male? And being a male. So since it says and, we can just find where male and other overlap. So male, other, that would be 10 over 100, which would reduce to 1 over 10, which would reduce to 10%. So your answer would either be 1 over 10 or 10%. When it says and, you're just finding that spot where they meet. All right. So let's keep going. Now we want to look at conditional probabilities. So conditional probabilities with the two-way table are kind of similar to what we've been looking at, but they have a specific condition they need to follow. So conditional probabilities, what is the probability that event B will occur given event A has already occurred? It restricts the sample space to a single row, column, or table. A single row or column table. Total. So it's just giving us another restriction we were looking at. So let's take a look at this. It says use the table, answer all the questions, write your answers as both reduced fractions and percentages. So let's start with A. A says find the probability of a student wanting to fly. Student wanting to fly. All right, how many students wanted to fly? 38, and then what was the total of students? 100. So we have 38 over 100. What does that simplify to? 38 divided by 100. Well, we know that will be 3%. And math, enter is another way to get the fraction. So 19 over 50. Or 19 divided by 50 times 100 gets us 38%. And that's the two things we need. 19 over 50 or 38%. Now we want to find the probability of a student being a female. So let's go find the female column. How many females answered this? 52. So we have 52 over 100. So that gets us 52 divided by 100. Math, enter to get the reduced fraction. 13 over 25. And then we have 13 divided by 25 times 100 gets us at 52%. So 13 over 25 or 52%. All right. Now it says, given the student chose to fly, what is the probability that that student was a female? So that says, given the student was chose to fly. So when it says something along the lines of this, we're given a condition. The condition has to be that the student chose to fly. So what did they choose to do? Fly. So we're going to go to the total of the fly column, and that's going to be our new total. So what is going to be our new total instead of 100? 38. So we have 38. And then that the probability was a female. How many of those 38 students were female? 12. So we have 12 over 38. So we have 12 divided by 38. Let's reduce that fraction. Math, inner. And that got us 6 over 19. There's our reduced fraction. And let's divide 6 by 19. We got this really funky decimal, but we remember we multiply it times 100. And we round that up to 32. So 6 over 19 or 32%. We're given a condition, and once that condition is, we'll go to the total of the condition. So let's see the next one. It says, of the male students. So now the total we're looking at is the total of the male students, which was 48. So we have over 48. What is the probability of choosing invisibility? How many students chose invisibility of the male students? Well, that was 12. So we have 12 over 48. Let's reduce that fraction. 12 divided by 48. Math, inner. 1/4. So 1/4 of the males chose invisibility. And now let's turn that into a percentage. So that's dividing it times 100. And we get 25%. So 1/4 or 25%. And yeah. All right, and now we have one more conditional we want to look at. It says, consider the students that chose other. Consider the students that chose other. So we'll now, since it says other, we will go to the total of the other, which was 18. So over 18. What is the probability of that student being female? Well, how many of the 18 chose female? Or how many of the 18 that chose other were female? Sorry, that would be 8. So we have 8 divided by 18. Take it as that reduced fraction. And that's 4 over 9. And then we'll do 4 divided by 9 times 100. And that got us 44%. So we have 4 over 9 or 44%. All right. So that's it for probability on two-way tables and all of the forms, conditional, non-conditional, all that good stuff. If you have any other questions, you can hit up your teacher. I'm sure they'd love to help you. This has been Miss Moncrief, and it's been a great day. Have a lovely, lovely, lovely day.